Hi there, welcome to today's lesson. Today we are looking at how to use inverse of a matrix to solve simultaneous equation. Before I go on, don't forget to subscribe to our channel. Just click on the subscription button and then click also on the notification button so that anytime we post a video, you'll be the first person to have a feel of it. And also don't forget to comment, write a comment in the comment section, whatever you think, where we have to improve or where we have to you have to comment us, and also give us a like if you think the video is okay, and then tell us which video you want us to post next. We will do that, right? But of course, if you want any information, just call us on 0549169506, right? All right, let's move on straight to today's lesson. We are looking at how to solve this simultaneous equation using inverse. The last time we used determinant to solve these simultaneous equations, right? Alright, so I have two simultaneous equations here. We are using the same thing that we used for the determinant. These are the answers. So let's see if we are going to get the same answer when we use inverse to solve this simultaneous equation, right? Of course, so let's first write this the equations equals 5. This is my equation 1. And then I have 2x minus 4 minus y equals 8, right? This is my equation 2. So let's write this one in a matrix form. So we have 3, 2, 2, then 1, right? And then xy gives me 5, 8. So of course, if we let M represent the matrix 3, 2, 2, then 1, right? Then we first have to find the inverse of M, okay? So if we want to find, but remember before we find inverse of M, we have to find determinant of M, right? So we first find the determinant of M. That's going to be what? 3 times 1, that will be negative 3, minus 2, 2, that will be 4, that will be negative 7, right? Alright, so we find the inverse of M. So now M inverse is going to give me 1 over determinant of M, that is negative 7, times the adjoint of M. But you know, the adjoint is we interchange the leading diagonal, right? So negative 1 comes here, and then 3 rather goes there. Then we exchange this, we negate this, sorry. So negative 2, negative 2. Alright, so this is our inverse, okay? This is our inverse. So what we are going to do is that with matrix, with inverse to solve a simultaneous equation, after finding the inverse, we multiply with this side of the equation and then this side of the equation, okay? So what we are going to do is that we multiply the inverse. This is my inverse, right? Leg 2 and then 3. We multiply the inverse to this side of the equation. This side of the equation is what? 3, 2, 2, leg 1. And then xy. So look at what I've done. I've multiplied this inverse that I have to just this side of the equation. Equals, I also multiply it to this side of the equation. So I multiply the inverse here, I also multiply it there. So this one becomes 1, neg 7, which is my inverse, neg 1, neg 2, sorry. Yeah, which is my inverse, neg 1, neg 2, neg 2, 3. Multiplying 5 and then what? 8. Of course, I told you that whenever you are multiplying a matrix and a vector, you don't bring the vector first. You bring the matrix first. When we're doing multiplication, I think I told you that. But remember that we said when a matrix multiplies its inverse, it gives you an identity matrix. Do you remember that? So, and we proved that, right? So, since this one is multiplying its own inverse, this is going to give us 1, 0, 0, 1, right? Multiplying xy. So what we have to do justice to is this one. So let me expand it now. 1 times 5, negative 1 times 5 is going to give me negative 5. And then negative 2 times 8 is going to give me negative 16, right? Alright, and then negative 2 times 5 is going to give me negative 10. And then 3 times 8 is going to give me 24. Is that also? It's going to be 24. So now, this is a unit matrix. When a unit matrix multiplies any number of variables, you get the same thing, right? You get the same thing. It's like one in the enumeration system. So this one gives me the same as what? XY. You can try it and see. 1 times this will give you 1x, and then this gives you 0y. So you just get x. This and this will give you 0x. This and this gives you y. So you still have your x and y. Okay. So equals 1 on next 7. -5 and then -16 is going to give me -21. Now -10 plus 24 is going to give me 14, I guess. Yeah. So at the end, my xy, when I multiply, this is the same as -21 on -7, and then 14 on -7. And this is going to give us, 7 on 21 gives me 3, and then 14 on 7, this one gives me -2. So if you realize, we've gotten our x to be 3 and our y to be -2. Are you okay? All right, so let's solve the second one. So let me clear this particular question. Okay, so let's do the next one. The next one, we have 7x equals 3y plus 7. I have 5y equals 6x plus 11. Rearranging it in equation form, we have 7x minus 3y equals 7. This gives me equation 1. And then, I brought this one here, right? So bringing this one here, minus 6x, it's positive. When it crosses, it becomes negative. So this is positive, so 5y equals what? 11. This is equation 2. So writing it in a matrix form, we have 7, next 3, next 6, 5. Multiplying xy gives you what? 7 and 11. Is that also? Now, if we let M be our matrix, 7, next 3, next 6, 5. Of course, so we first find our inverse of M. By finding the inverse of M, we first have to find the determinant. So my determinant of M is going to give me, this is 7, next 3, next 6, and then 5. So this is going to give me 7, 5, 35, minus 6 times 3 is going to give me 18. And 35 minus 18, I think it's going to give me 17. Yes, it's going to give me 17. So let me find my inverse. So my M inverse is going to give me 1 over 17 times the adjoint. The adjoint is interchanging the leading diagonal. So 5, 7. If I negate this one, I'll get 3 and then 6. They're already negative. So when I negate them again, I'll get positive. So as usual, we multiply the inverse with this side of the equation and also that side of the equation, right? So what we do is that we have our inverse 1 on 17, 5, 3, 6, 7. So multiplying this side of the equation, that is 7, next 3, next 6, 5, and then xy. Multiplying this side to, we have 1 on 17, we have 5, 3, 6, 7. So multiplying, this is 7 and 11. Is that also? Alright, so of course, we know when M inverse multiplies itself, we get an identity, which is 1001. So this one gives what? 1001 multiplying xy equals 1 on 17. Expanding this one, 7, 5, 35, right? So we have 35 plus 3, 11, 33. And then we have 6 times 7, that will give us 42, plus 7, 11, 77. So at the end, this gives us xy, because any variable when multiplies a unity matrix, you get identity. So equals, I have 1 on 17. Now 35 plus 33 is going to give me 68. And then 42 plus 77 is going to give me 119, I think. Yes. So expanding this one, you realize that if you multiply 1 on 17 with 68, you are going to get 4. And if you multiply 1 on 17 with 19, you are going to get what? 7, right? Which gives you x equals 4 and y equals 7. Okay? Alright, so this is where we draw the curtain. This is actually our last episode on matrix. This is the end of matrix. But we have one more where we'll solve past questions. So make sure you look at that. That's the end of that. Then after that, we are going to look at linear transformation. You know, matrices are in two parts. We have matrix itself and we have matrices and linear transformation. So on our next lesson, we are going to look at linear transformation. So until we meet next time, I'll say thank you for now.